Yes, welcome. So in this video, we're going to derive expressions for the acceleration in the system. So you have two blocks connected with some kind of rope, and an external force F is applied to the system. So our objective is to do the following. Derive an expression for the acceleration and then for the tension present in the connecting rod, meaning this rod here, okay, a piece of rope. Okay. So you isolate the blocks. The block, this one here is the following. We describe it using Newton's law. So you have T equals m1a. Now, what is common to this kind of situation is the fact that when you pull here, it's a rigid system, which means that there's only one acceleration that is the same for both blocks. Okay, which means now you focus on the second block. You will have here F minus T equals M2A, like that. There you go. Okay, so when you focus on block 2, the tension here might be said to point in that direction, the applied force acts in that direction. So now that we have this in place, guess what? Our objective is to find acceleration, and the acceleration is common. So what can you do? Well, what you can do is in this equation replace t with m sub 1a. So you'll have f minus m sub 1a equals m sub 2a. At this point, what you want to do, of course, is add this term to both sides. So you'll have f equaling m2a plus m1a. Then you factor a because it's common. So you'll have a equals f divided by m2 plus m1. And this is the expression for the acceleration of the system as a whole. So as you can see, it depends on the force, and it depends on the sum of the masses also, as you might expect, right? In other words, you can think of it almost like saying the acceleration of this two-body system is the same as if I had one block whose mass was the sum of the two individual masses. Okay, that's how you might also think of it. All right, and now at that point, the next step is to derive an expression for the tension. So tension equals m1a, so you replace a with this. In other words, you'll have the tension equals m1 and replace a with that. So you'll have f over m2 plus m1, and there's the expression for the tension, and that is it. So thank you, have a magnificent day.